Hello everybody, this is a demonstration on Beastly Rivals Onslaught, short BRO. BRO is a multiplayer online survival arena, which can be played with up to 8 players. Being a king of the hill kind of game, the last man standing wins. All players are located on this pitch to fight each other. One player receives a ball, and whoever is in possession of that ball is chased by the beast. Once the beast reaches the ball carrier, the beast kills him. So to survive, you have to pass the ball to someone else. Over time, the beast gets faster and more accurate, thus the chance of survival is decreasing. Besides moving around and passing the ball, the players can blink to any location on the pitch. This ability is on cooldown after its usage. Also, the ball carrier can charge a power shot. The next pass will be blasted to its target. This affects the speed and the accuracy of the beast as well. Now, I would like to briefly show you BRO's AI framework, which has been designed in a way that developers can start implementing AI right away. For this purpose, only 2 classes are necessary. The first class has to derive from AI base. The other one may derive from mono behavior, AI behavior, or AI event listener. Let's jump into the implementation of the tutorial AI to get some more details. So this is the AI base class for the tutorial AI. Deriving from AI base requires to override 2 functions. One is get AI information. This function is in charge of distributing certain metadata to the game. This data is displayed during the process of adding an AI to the match. There's a name of the AI, a description, an offer, and such things. The other function is add AI components. This function is supposed to add all the logical AI behavior components to the player's game object. So in this case, this is tutorial AI. And tutorial AI derives from the AI event listener. Now let's go back to the documentation and see how this inheritance hierarchy plays out. So on the very bottom, there is mono behavior, which is a typical component class in Unity, which can be added to a game object. Then the AI behavior is deriving from mono behavior, and the AI behavior possesses information about the control player and its action space. And on top of that, there is the AI event listener, which enables developers to listen to certain events, like the start of a match, or a ball got passed. Now about the simple behavior of the tutorial AI. The agent listens to the ball caught event, and if the agent is in possession of the ball, he directly passes the ball to a randomly selected enemy, and while not in possession of the ball, the agent chooses to gain distance toward the closest enemy till a certain distance is reached, otherwise it moves into a randomly chosen direction. And for this logic, the AI needs more information about the match itself. This information can be retrieved from the game state object, which is a static class which can be accessed from anywhere basically. And the game state class provides all the relevant information about a match, its players, the ball carrier, the beast, and so on. And in a nutshell, this is everything what one needs to know on how to create an AI behavior for BRO. BRO is a use case for conducting learning AI research. For this particular reason, a match automation was developed, which enables the developer to set up a sequence of matches and to let them run off hands. So this is now the match sequence editor. This is a typical CRUD interface. Matches can be added, deleted, modified, reordered, saved, load, and so on. The checkbox, for example, can alter a match to have infinite lives, to maybe just have one match being run for the whole time. A tag can be set, a name can be set, a description can be set, a color can be set for documentation purposes, and of course, the actually participating players can be customized. So, and there are some sequence settings. A lap count can be specified. or it can run infinitely until the user aborts the automation, and each lap can be shuffled. So, and during the actual match automation process, the bottom bar displays the current progress and the state of the automation process. And the simulation speed can be increased to make it run a lot faster. Besides that, the automation process can be aborted after the current match or right away. And this is helpful for training a behavior under the circumstances of having no data set previously. So this is for generating training data basically.